All right, number 21. A project manager estimates that a project will take X hours to complete where X is greater than 100. The goal is for the estimate to be within 10 hours. So I guess that's important. We want to be within 10 hours of the time it will actually take to complete the project. If the manager meets the goal and it takes Y hours to complete the project, which of the following inequalities represents the relationship between the estimated time and the actual completion time? Well, right off the bat, I'm kind of looking at D, and that one's kind of making sense because in a project, you don't want to be 10 hours above, so that's bad, and you don't want to be 10 hours below. That's bad, right? So you want to be in that nice range of either being plus 10 or minus 10. You don't want to finish the job too long. You don't want it to be completed too quickly. So the only one that really shows that is choice D, because you have the actual time. Remember, Y is the actual time that it takes minus the expected. And that kind of describes what we talked about. We want to be less than 10 hours, but we also want to be greater than negative 10 hours or being under 10 hours. So this is your best answer, and that's honestly the best way to think about it. I wouldn't even plug in numbers for an example like this. All right, number 22. This one shows us an equation at the top of the screen here. And before I even read anything, I just noticed in my answer choices that everything is r squared, r squared, r squared, r squared. So I'm not even going to read this right away because I know I have to get r squared by itself. So let's just do that. This is how you can save some time. So I'm just going to put the I over 1 and cross multiply. So that's P equals I 4 pi r squared. And I divide by I 4 pi, I 4 pi, boom, boom. R squared equals P over I 4 pi. And which one is that? P over I 4 pi. That's choice B. We're done. All right, so now on to number 23. It says, for the same signal emitted by a radio antenna, observer A measures its intensity to be 16 times the intensity measured by observer B. The distance of observer A from the radio antenna is what fraction of the distance of observer B from the radio antenna? So they're asking us, basically they're saying, and I'll just read that last part, the distance observer A from the radio antenna is what fraction of the distance from observer B? So basically they're saying how much closer or how much more close is observer B. So what I like to do is in a situation like this, I'll just rewrite my equation. Sometimes you do that just to stall for time and you kind of let your brain think of how to do it. But I'll show you the way I solve this one. Our intensity, it says, is 16 times what this guy measures. So let's just say this is observer A here. Observer B, the intensity is 16 times that. Well, if I multiply this by 16, the left side, I got to multiply the right side by 16. So that's P 4 pi r squared. So how do I get the right side to be increased or multiplied by 16? Well, I'd like to take the distance r, and if I make r a fourth, right? So he'll be 1/4 as close, or 4 times closer. If I make this a fourth, what is 1/4 squared in denominator? Well, that's a 16th in the denominator, and well, we know when as a fraction in the denominator, you flip it. So that's one way of getting 16 on the right, and that's probably, I would think, the quickest way of doing it. That's all you got to do. All right, so for number 24, this is a completing the square question. The equation of a circle in the xy plane is shown above. What is the radius of the circle? So here's what you're going to do. First, organize your terms. X squared plus 4x. I'm going to put plus, and we'll leave a space. And then we'll do plus y squared minus 2y, and then we'll leave a space, equals -1. So to complete the square, we're going to take half of this number and square it. So half of 4 is 2, 2 squared is 4. And we're going to use the sign to help us. Half of -2 is -1, squared is 1. So now, I added 4 here, I added 1 here. That's a total of 5. That means I have to add 5 to the right side of the equation to balance it out. So now, the whole point of completing the square is being able to make a double bubble. So this is going to be x plus 2 squared, and this is going to be y minus 1 squared. And if you foiled this out, and you know, everything would work out. I'm just writing this under. This isn't extra work, but just to give you an idea, this turns into this. And you know, if you did x plus 2 times x plus 2, you could check it, but you know, to save time on the test day, you wouldn't want to do that. That turns into this. So everything equals 4, and we know the radius of a circle when it's in this format, which is the whole point of doing this. We want to get everything into this format. The radius is just the square root of this number. So it's 2. You're done. All right, number 25. This one says the graph of the linear function f has intercepts at a0 and 0b in the xy plane. If a plus b is 0 and a does not equal b, which of the following is true about the slope of the graph of f? So again, my big tip with these questions, I would just draw a picture, you know, pick some numbers. Why don't we make this -2, 0, and this could be 0, 2. And you could just draw a quick picture. So -2, 0 is here, and 0, 2 is there. So that's positive. And you could maybe pick different numbers. Since this first one is negative, why don't we make this, 3, 0, and then this one could be 0, -3, right? And that makes sure that satisfies this whole a plus b is 0, right? This is 3 and this is -3. So if I draw that one real quick, 3, 0 is there, and 0, -3 is there. And once again, slopes are positive, right? Positive slope, positive slope. I'm going to be fairly confident that's positive. I'm going to move on. 26. So let's look at this one. The complete graph of the function f is shown in the xy plane above. Which of the following are equal to 1? So when they give you answers in this format here, let me zoom out. F of -4, that literally means plug in x equals -4. And what's the answer? What does that give you? Or what's your y value? So x of -4, 1, 2, 3, 4. Oh, it's 1. There's your y value. This one's good. F of 3 halves. Well, 3 halves is the same thing as 1.5, right? So 1.5. So we go to 1.5. What happens when I go to 1.5? Oh, what's my y value? It's 1. Cool. F of 3. 1, 2, 3. Oh, what do you know? It's 1. We're good. All 3. 1, 2, 3. Done. All right, number 27. This one has a graph. Looks like we've got insulated and non-insulated objects, and we'll take a read. 2 samples of water of equal mass are heated to 60 degrees Celsius. One sample is poured into an insulated container, and the other sample is poured into a non-insulated container. The samples are then left for 70 minutes to cool in a room having a temperature of 25 degrees. The graph above shows the temperatures of each sample at 10-minute intervals. Which of the following statements correctly compares the average rates at which the temperatures of the 2 samples change? Okay, so really what you're trying to look at here when they say average rates of change, for the insulated one, you're looking at from here to here, then here to here, then here to here. And then for the non-insulated one, you're looking at that rate of change, that rate of change, and that rate of change. So just by first glance, it kind of looks like the non-insulated one has a very steep rate of change in the beginning, and then it levels off. And then for the insulated one, it's kind of shallow, or it's steep, and then it's kind of constant, but it looks like at the end here, it's a greater rate of change towards the end. So they're kind of flip-flopped. All right, so we want to figure out what answer that is. And honestly, I'm just going to save time because I don't feel like reading every single one. I looked at this one beforehand just because I knew it would suck up a lot of time. So I just want to show you that answer, after you read everything, that's choice D. So let's just read it. In the intervals from 0 to 10 minutes and from 10 to 20 minutes, the rates of change of temperature of the non-insulated sample are of the greatest magnitude. So they're saying early on, the non-insulated has the greatest rate of change. So let's look at that. Early on, the non-insulated has the greatest rate of change. And that's true, early on from 10 to 20. Now let's just read the second part of it. Second part says, And from 40 to 50 and 50 to 60, the rates of change of temperature of the insulated sample are the greatest. Well, that kind of makes sense, right? Because we look back and we said, well, the insulated one, I'll use a different color, insulated one kind of goes from there to there, there to there, there to there, whereas this one was kind of flat. So that's true. So you got to go with choice D and just move on. Kind of a lot of reading, but the main thing is to understand the rates of change. So you're just looking from point to point. And you're basically just looking at steepness. All right, so let's look at this next example. This is number 28. Okay, so what's going on here? We got the square, we got a couple points. In the XY plane above, ABCD is a square and point E is the center of the square. The coordinates are the points of points C and E are 7, 2, and 1, 0 respectively. Okay, so maybe I'll write that in. C is 7, 2, and E is 1, 0. Oop, 1, 0. Okay. Which of the following is an equation of the line that passes through the points B and D? Okay, so we want the equation of that line right there. Well, first of all, we have to know that it's going to be the negative reciprocal of the slope of this line. So if I can figure out the slope of this line, the slope, let's do that. The slope of EC. So that's going to be 2 over 0, change in y, 2 over 0, and 7 minus 1, which is 6. So it's a third. So if the slope of this line right here, if the slope is a third, that means the slope of this line is going to be -3. Okay, so that's the rule, negative reciprocal slopes. And the reason you have that is because it's a square, and these lines are perpendicular. They create 90-degree angles. So you could go around and do this. I'm not going to prove that right now. You just got to take my word for it. In a square, the diagonals are perpendicular. So that's why you have negative reciprocal slopes. So knowing that, which one of these has a slope of -3? Well, right off the bat, we can get rid of this one and this one. And I'll just rewrite the second one here. That's -3x plus 3. So what is this number? So since we have two choices, right? Both of them have a slope. Remember, that's the spot for your slope, the number in front of the x. So this number, the one in the back here, is your y-intercept. And that's where it hits the y-axis. So there's a big difference here because one is the y-intercept is 3 and the other is -1. So let's just go back and figure out where our y-intercept is. Well, where is it? In this line, it's going to be up there. So it's going to be 3. So we want the graph that has a y-intercept of 3. Actually, that was probably the best way to do it, come to think of it. Yeah, I'm realizing this now. If you rewrote this as 3x plus 3, you really didn't even have to do that much work. You could have just said, well, they all have different y-intercepts. Where's my y-intercept going to be? It's going to be there at 3. All right, so that's a faster way to do it. Cool. All right, we're doing number 29. This one says, in the system of equations above, a and b are constants. For which of the following values of a and b does the system of equations have exactly 2 real solutions? Okay, so maybe the first thing you would do in this question is just draw a quick graph of where this equation is going to be, y equals 3. And I'll show you why you don't really have to do much work for this problem. You can, you don't want to be plugging things in. You don't want to be doing, this is one of those problems you can do less. When they say do less, this is one of them. Okay, so now this equation here, we got this one done. What kind of equation is this? Hopefully you should be saying it's a parabola. And the most important piece of information they give you, I would say, is right there, is actually the b value. That's your y-intercept, okay? And that tells you how high up or how low the graph is going to be. So why is that useful? If we want this system of equations to have exactly 2 real solutions, that means that it's got to intersect it like this, either going up, like a smile, or it's got to go down like that. It's got to hit it in 2 spots. So now let's just think logically. If our b value is 2, and this is facing down, it's frowning, right? Because the number here, the a value, if that's negative, it's going to frown like that, okay? Negatives do that, positives do this. Okay, they smile. So if we have an equation that's negative in the front and the y-intercept is 2, it's going to do this, right? So that can't be the answer. Real quick right here, this one frowns as well. But where's the y-intercept? How far up do we go? We actually go 4 units up, and I'll just go one more higher than that. And I kind of gave the answer real quick. It's actually going to go down. I drew it a little wider, but they look pretty much the same, and it's going to hit in 2 spots. Okay, so that actually B is your answer. And if you didn't believe me, let's just go logically through the rest. C, it is your y-intercept of 4 again, right? But what does the graph do? It's positive A value, so it smiles. It goes up. So it actually never hits our line of y equals 3, so that's gone. And you tell me what's wrong with this one. Well, kind of the same stuff, right? We've got a line that has an intercept of 4, an intercept of 3, intercept of 3, but it's positive, a positive A value, so it's going to smile. It's going to go up. And actually, it didn't matter if it was positive or negative because it only hit in that one spot. So that's how you do that logically. You just kind of think it out. I know it took a little longer to explain it because I went through every one, but you should kind of know your rules. Just know that that's the y value, or excuse me, the y-intercept, and that'll move your graph up and down. All right, number 30. This one says the figure above shows a regular hexagon with sides of length A and a square with sides of length A as well. If the area of the hexagon is 384 radical 3 square inches, what is the area in square inches of the square? I feel like I said square like 9 times. Okay, so the nice thing about this problem is that it's a regular hexagon. So who cares? Why does it matter? Well, what you're going to do is this. You put your little point in the center there, and you're going to connect all of these to the corners. So because of that, you've actually made 1, 2, 3, 4, 5, 6 triangles, right? And they tell you that the area of the entire hexagon is 384 radical 3. So 384 rad 3 divided by 6 for each of those triangles is going to give us the area of each triangle, right? So right now we're just figuring out the area of one of these triangles. Okay, cool. So when we divide by 6, what do we get? We get, I don't even have my calculator on me. I think it was 64. Yeah, 64 rad 3. Okay, so the area of one of those little triangles is 64 rad 3. Okay, so the next step is, how do I use that to help solve for the square? So the nice thing about a regular hexagon, and you can prove this using the old formula n minus 2 times 180, okay? And that tells you where n is the number of sides. So 6 minus 2 times 180. So anyway, so this will tell you the sum of the interior angles. And when you do all that work, basically you find out that each one of these angles here is 120 degrees. I'm not going to go through it, but just trust me, each one of these is 120. And if that means each one is 120, in a regular hexagon, when we do all the crosses here and connect all the corners, that means each of these is 60. So because this is 60 and this is 60, by default, the missing one has to be 60. So why is that important? You actually have an equilateral triangle. Now some of you may be going, all right, well, so what? Well, the old school way of doing this would be you just drop the height down, you make a 30, 60, 90, and then you relate that back to your area. But what I'm going to do differently today is I'm just going to tell you that you're going to use the area for an equilateral triangle, and that area is radical 3 over 4 times the side squared. Since they're all 60, all the sides are equal, so right? So all these sides are equal. So the area of an equilateral triangle is radical 3 over 4 a squared. Nice little nifty thing to know. Okay, so if the area of the triangle is 64 rad 3, and that's equal to rad 3 over 4 a squared, I'll multiply both sides by 4. I'll multiply by both sides by 4, right? Because that cancels out, that cancels out. And there's a radical 3 on both sides, so that gets taken out on both sides. So 4 times 64 is 256. 256 equals a squared. So the nice thing about this, I don't even have to do any more work, right? Because it was saying that one of the sides we called A, right? Well, they're all really A. And whatever they are, that side of the equilateral triangle is also the side of the square, right? That's that one. It's a square, so all of these are equal. So one of the sides of the equilateral triangle is equal to that. So it turns out we're done. We don't have to do any more work because A squared is 256, which turns out to be the area of the square. And that's it. So I just did this a little differently because I wanted you to know the area of an equilateral triangle. And that's that equation right there. It's just radical 3 over 4 times a side squared. So your answer is A. And you're done. All right, number 31 is one of those questions. If you got this wrong, you might want to have to reevaluate your life. This one says, a coastal geologist estimates that a certain country's beaches are eroding at a rate of 1.5 feet per year. According to the geologist's estimate, how long will it take in years for the beach to erode by 21 feet? And literally all you had to do was 21 divided by 1.5. How many times does 1.5 go into 21? I'll put feet here anyway, but you don't have to. And you get 14. And that's literally all you have to do. You could set up a proportion, but let's not make this overcomplicated. That's all you got to do. All right, number 32. Let's see. If h hours and 30 minutes is equal to 450 minutes, what is the value of h? Okay, so if h hours and 30 minutes, I gotta read this twice, is equal to 450 minutes, all right, so you could just say h hours is really in minutes. It's gonna be 60h is gonna be in minutes, all right, because we put the 60 in front of it. So 60h plus 30 equals 450. I'm gonna minus 30, I'm gonna minus 30, I get 60h equals 420. I'll take off the zeros on both sides. I'll divide by 6, divide by 6. And that gives you h equals 7. That's it. The key thing is just if it's in hours, you got to multiply by 60 to make it minutes. That's it. All right, number 33. In the xy plane, the point 36 lies on the graph of the function f of x equals 3x squared minus bx plus 12. What is the value of b? This is really just kind of like a notation question. So you can either think that this is x and that's a y value, or another way to think about it, and this is the way you're going to think about it for this problem. If that's x, this is f of x, right? Because y is the same thing as f of x. So let's just plug in. We know that x is 3. So 3 times 3 squared minus b times 3 plus 12 gives us our y value, gives us our f of x, which in this case is just 6, just plugging in. So now we're just going to do the algebra. 3 squared is 9, 9 times 3, 27 minus 3b plus 12. We're going to combine 27 plus 12. That gives you 39 minus 3b. I'll minus 39 minus 39. Cancels out. That's going to be negative 33. Equals negative 3b, divide by negative 3, divide by negative 3, bippity boppity boop, b equals 11, and you are done, and that's it. Let's move on to the next one. 34. One semester, Doug and Laura spent a combined 250 hours in the tutoring lab. Okay, if Doug spent 40 more hours in the lab than Laura did, how many hours did Laura spend in the lab? Easy way to do this. I'm just going to write Doug, and we're going to write Laura. And whoever the smaller one is, or we're just going to call it x. So Doug spent 40 more hours. So Laura is going to be x, and Doug is going to be 40 more than that. Okay? And they spent a total combined of 250. So now you're just going to add these two. X plus 40 plus x, I'm just adding the top and the bottom, equals 250. More algebra. 2x plus 40 equals 250 minus 40 minus 40. 2x equals 210. Divide by 2, divide by 2, and you get x equals 105. Now we just have to make sure we're answering the question, right? Because how many hours did Laura spend? Oh, 105. All right, you're done. That's it. All right, number 35. Jane made an initial deposit to a savings account. Each week thereafter, she deposited a fixed amount to the account. Okay. The equation above models the amount A in dollars that Jane has deposited after T weekly deposits. So basically, I'm just going to translate here. A is the final amount after T, the number of weekly deposits. So we don't know what the final amount is. We don't even know how many weeks she did. It looks like she's depositing $18 a week from the equation for some amount of weeks. Okay. What do we want to know? According to the model, how many dollars was Jane's initial deposit? And I'll tell you, in equations where you have some value off and alone by itself, that's usually your starting value. Like if this was how much someone's going to charge you to clean their house, they might say, it's $18 an hour. But just to show up at your house, I'm going to charge you $15. It's a flat fee. And that's exactly what's going on here. It looks like she just deposited $15, right? And whatever she, however many weeks pass by of her depositing $18, you'll get a final answer. So always look out for the number that's kind of sitting by itself. All right, that's usually like your initial deposit or initial fee or something that occurs unrelated to the amount of time. Usually your starting value. All right, so your answer is 15. All right, number 36. This one we've got a picture here of a circle and kind of looks like a diamond or something hanging off the side. In the figure above, point O is the center of the circle. Line segments LM and MN are tangent to the circle at points L and N respectively. So what I have to do right off the bat, when I hear tangent to a circle, you make 90-degree angles. And if you didn't get this question, maybe that's what you did wrong. So there's 90-degree angles there and there. And the segments intersect at point M is shown. Okay, let me just go down here. If the circumference of the circle is 96, what is the length of minor arc LN? Let me put those 90s back where they were. Okay, so those are 90-degree angles. So they want to know, what is this length here, minor arc LN, the distance from there to there. And this problem is very simple. I'll show you why. First thing you're going to do, I don't like this weird shape here. I don't know what the heck that is. My brain doesn't like it, but I do like triangles. So I'm splitting that in half. So when I split that in half, that's 30 and that's 30. So now I have a 30 something 90, right? Because that's this triangle here. Hopefully you saw that. So that's a 30, 60, 90. Well, if that's a 30, 60, 90, this one's a 30, 60, 90. Makes sense, right? So now, this angle is 120 degrees, and that's going to be the inscribed angle of that arc. So 120 degrees gives you arc LN, right? What does 360 degrees give you? Well, all the way around gives you the distance around the circle, which we call what? We call it the circumference, which was 96. Sorry, I got to put this back together now. So the circumference was 96. So all you got to do is you got to think, if 120 is a third of 360, what's a third of 96? And your answer is 32. And you're done. That's it. Move on. All right, number 37. This one says a botanist is cultivating a rare species of plant in a controlled environment and currently has 3,000 of these plants. The population of this species that the botanist expects to grow next year, end of next year, can be estimated from the number of plants this year, end of this year. Okay, blah, blah, blah. So you got this equation, and basically it's just telling you that next year's crop is this year's plus 2/10 of this year times this factor over here. And they've got a K in there. It tells you that's the number of plants the environment can support. And if we go down here, let's figure out what they want to know. According to the formula, what will be the number of plants 2 years from now? So that's the main piece of information, 2 years from now. If the K is 4,000. So let's just plug into our formula. So next year is going to be, we said this year there was 3,000 plus 0.2 of 3,000. and that part is times by 1 over 3,000 all over 4,000. So 3,000 over 4,000 is 3/4. All right, and let's see, 0.2 times 3,000 is 600, right? So 600 times 1 minus 3/4 is just 1/4 or a quarter, and that's still 3,000. And what is a quarter of 600 is 150. So this is 3,000 plus 150. You should get 3,150. But you can't circle this and be done because you got to plug this in again because it's 2 years. This is just the first year. Okay, so now let's plug it in again. So we get 3,150 plus 0.2 times 3,150 times 1 minus 3,150. You tired of me saying that yet? Over 4,000. Now I might use the calculator just so that, what is that, 315. So that's 630. So 350 plus, 630 all times, and I don't know what 3,150 over 4,000. Let's figure that. 3,150 divided by 4,000. That's 0.7875. Okay, so 1 minus that, 1 minus 0.787, 1 minus 0.7875, 2125, okay, so let's go back and write that, 0.2125, and we'll just multiply now. Sorry, if I had my calculator, this might go a little faster. And then we'll just do that times 630 equals 133,875 plus 3,150. So 3283, 875. 3283. I can write it. 3283.875. And I want you to round to the whole number. So that's just going to be 3284. And that should be your final answer. Cool. And you're done. All right, number 38. This one says the botanist would like to increase the number of plants that the environment can support so that the population of the species will increase more rapidly. If the botanist's goal is that the number of plants will increase from 3,000 this year to 3,360 next year, how many plants must the modified environment support? So if you guessed it, modified environment, when they write that, they just want you to find the K value. So let's use their numbers to plug in. We got 3,360 next year, and I'm really just going into the formula, plus 0.2 times 3,000 equal, oops, sorry, not equals, it should be 1, that's a 1 there, 1 minus 3,000 all over K. That's the equation you should have. What we're going to do is there's a couple ways to do this. We can minus 3,000, we get 360 equals, what's 0.2? That should be 600 times 1 minus 3,000 all over K. Why don't we do this? Why don't we multiply both sides by 1 over 600? 1 over 600. We'll get rid of the 600 that way. We just got to know what that is. So 360 divided by 600 is 0.6. Okay, so we got 0.6 equals 1 minus 3,000 all over K. I can add 1 to both sides, or excuse me, subtract 1. So we get, I'm just doing the work over here, 0.4, it's a lot of work, equals, or excuse me, negative 0.4 equals negative 3,000 all over K. And then if you cross multiply, you get negative 0.4 K equals negative 3,000. And your last step is just to divide by negative 0.4. So that's going to be K equals negative 3,000 divided by negative 0.4. And you can just do that in the calculator real quick, but we can write it right. Oh man, I closed that out again. Calculator, I'll just do 3,000 divided by 0.4, and you should get 7,500. That's your answer. All right, cool. So there might be a faster way. I would just say on test day, you try and do your work as fast as you can. But if you guys come up with a better way, definitely let me know. All right, cool.